Okay. A van is travelling at a constant speed of 15 metres per second. So there we have it on the graph. At the instant when it passes a stationary car, the driver of the car gives chase. The car accelerates uniformly for 20 seconds until it reaches a speed of 25, then continues the speed until it overtakes the van. On the next row, sketch the speed time graph for the car. Okay, so first thing we're going to do is, if that's 15, we're going to see if we can get a bit of a scale. Okay, so that's about 3 centimetres. So every one's 5, so there's 20. There would be 25. Okay, so then next thing we're going to put a bit of a scale down here. So we need 20 seconds, so we'll say that's 10 and that's 20. So it takes 20 seconds to get to 25, so above 20 we'll go up to 25. It's accelerating uniformly, so it's a straight line, and then it maintains a speed, so then we have it going horizontally. So there's a sketch of the van and the car. Okay, next. Hence, the time taken for it to overtake the car. Okay, now, when something overtakes something, it's the same position, so it's covered the same distance. Okay, so if it's been going for t seconds, the distance travelled by the van is the area under the graph. So we'll say it's going to sometime t, we don't know when it is, we'll just say it's t. So the area under the graph for the car has to equal the area under the graph for the van at t seconds. Okay, so if we have a look at the van, this is a rectangle and it measures t by 15. So the distance of the car is 15t. The distance, oh sorry, that was the van, sorry. The distance of the van is 15t. And then the distance of the car, this is a trapezium. Okay, so it's half the sum of the parallel sides, so half of t, and then that's 20 less, so half of t plus t minus 20, times the distance between them, and the distance between those two parallel lines is 25. Okay, so now we know when they overtake, those two distances are going to be equal, so we get an equation. Okay, I'll just simplify this first. So that's going to give me half of 2t minus 20 would be t minus 10, so times 25, so it's 25t minus 250. So these two are equal, so we have 15t equals 25t minus 250. So bring that across, and you get 250 equals 25t minus 15t. So if 10t is equal to 250, t is going to be 25 seconds. So it's going to take 25 seconds for the car to overtake the van. Okay, now the next part we're asked, what's the distance the car has travelled? Well, we know the car has travelled the same distance as the van in that time, and the van's distance is 15t. So 15t is equal to 15 times 25, which is equal to 375 metres. Of course, you could put it into the other one, and then you go to half times 2t minus 20 times 25, and if t is 25, it's going to be half of 50 minus 20 times 25, and again it works out to be 375. It doesn't matter which one of them you use.